I wish to bring into our event our director, Water Division Director, Tom O'Donovan. Tom should be almost ready. I'm going to read a short description of your session, Tom, and then your bio, and then we'll have you begin. So Tom O'Donovan is currently the Water Division Director here at DES. He has 34 years in public service and in public service positions of increasing responsibility. Tom served as a senior leader of the U.S. Army Corps of Engineers, a senior manager within the Department of Energy, and as a project director in the construction industry. His credentials include a master's in civil engineering, registration as a professional engineer, and certification as a project management professional.
All right, so tell me what you think out of those 5 that you see listed there. Pick the ones that you're most worried about.
That's because you're presenting, Pierce. I do.
We need the Jeopardy music queued up there, Pierce.
I could try humming it, but I don't think you'd really appreciate that.
All right, look at that. Isn't that interesting? All right, well, thanks for that. I'll tell you that as Water Division Director and the years of experience I've got here and looking at those issues, I'll tell you I'm worried about all of them, deeply worried about them. And I would apply a variation of a saying that many of you know: if the Water Division's worried about it now and you're not, you will be. And that's the part I'd like to talk with you through a little bit today. So let's go ahead to the next slide, please, Pierce. So a little bit on my view. A lot of my view on climate change comes from my work with Dr. David Anderson. You see pictured in the middle there. Dave and I have been friends since the late 70s. He's my best man, and we're also climbing partners. And we've been climbing for decades. We're also mountain bikers, windsurfers, and all kinds of other stuff, long distance road biking. That's a picture of us ice climbing up in Vermont some years ago on the left. And you can imagine we've spent a lot of time hiking, biking, sailing, and that involves a lot of sitting around, sometimes under some pretty miserable conditions. And he is an expert on climate change. His particular work is paleoclimatology. His particular area of study is in that middle chart. He works to pull all the data together and develop data and science on the part of what's called the hockey chart that's before the big kick of the stick at the end there. Determine what has the temperature, the global temperature, been doing for the last 1,000 to 10,000 years is the area that he studies the closest. I feel like I've got at least a minor degree in climate change from his point of view and from NOAA's point of view and of the science that supports that. And so I've drawn some pretty strong conclusions of that. And then when I arrived here at Water Division at New Hampshire DES, I got introduced to the Northeast Climate Impacts Assessment of 2008, which was a really substantial effort at that point to pull everything together. And this chart on the right really describes my viewpoint very, very well. New Hampshire's moving south. And in fact, by 2079, 2099, it's going to be in Virginia. In my view, I lived in Virginia at different points along my career in different ways, and I didn't like it. I didn't like Virginia. There are a lot of ticks there. And now you heard earlier today, there's more ticks coming here. And there's a lot of other aspects to Virginia, humidity and other things. I like Virginians, don't get me wrong. But I didn't like it. And that is where New Hampshire is going. Sherry Godlewski laid it out in really good detail from a global and a national scale. And so over these next few slides, I'm going to try and bring it into a state viewpoint of what we're after. I'm going to be a little bit provocative in some things. You can do that. You can do that when you're about 10 days out from retiring from DES. You kind of, I mean, this is not a take this job and shove it type moment, but it is an opportunity to give you some insights as the way that I see them. And I'll also say that You know, between what was laid out earlier today by our various speakers, those excellent presentations from across New Hampshire, and Sherry's work that she's laid out globally and nationally, well, it's kind of like a Monet painting. You know, we're painting by dots here. And for those of you who are really paying attention, a picture is beginning to appear. We want to help you put some more dots on the screen on the picture to help you pull those together so we can all fulfill our responsibilities. Next slide, please. My view is also colored by an experience that I had in 2007. I was asked, I was a senior exec with the Corps of Engineers at that time. I was asked to go to China as part of the Second Yangtze River Forum, run in Changsha, China, a very important city in China. It's where Mao Zedong taught at university. And I was the deputy head of the US delegation for that trip, a very substantial event. I was the first uniformed, at that time I was a uniformed commissioned Army officer, first uniformed Army officer to be in Changsha since MacArthur was, senior representatives of the Army had been there back in the 40s at the start of the Chinese Revolution. Fascinating, absolutely a viewpoint changing experience as I heard about what China had done on the Three Gorges Dam, which you see picture on the left, one of the largest dams in the world and one of the most environmentally impactful dams in the world also. And then heard all these other countries talk about different aspects of climate and environmental impacts of climate change as they saw it at that time. Very progressive effort by China, given the political structure that they operate under, but a game changer for me in terms of my view. Next slide, please. And then some of you have seen this slide before. This is sort of Tom O'Donovan's view of the spectrum of climate change response that I believe we're in right now. We have all the way from the far left-hand side, as you're looking at it, the stop and reverse global warming that Sherry talked about in terms of reducing greenhouse gas emissions like CFCs and others, or reducing atmospheric carbon contamination, or solar geoengineering, which is now starting to be talked about in a very real context. All the way through to proactive adaptation, managed retreat, risk-based designs, that is designing our facilities based on what we think the risks are and trying to mitigate those risks, or developing resilient systems that can handle what we anticipate being the changes. And then all the way to the far right of Darwinian adaptation. That is, like in Japan. For example, Japan has taken a somewhat Darwinian adaptation to earthquakes. Their society has been rocked by major earthquakes. Buildings that couldn't handle it fall down. They rebuild them in the structure of the buildings that could handle it. They've been doing that for 1,000 years. And now Japan can handle earthquakes that other societies can't handle because they've used a Darwinian approach to do that. My estimate is that we're about there on the right-hand side is where you see the arrow. We're using our Darwinian approach. Many communities are adapting and investing in the different approaches that we described, and many are not. And we're going to find out which ones do or don't, which ones bet wrong, and where they end up at the end of all this. And that's not necessarily a good public policy, but I sort of assess that that's where we're at. We can talk about that some more in Q&A if you'd like. Next slide. So based on some of those views, let's talk about, let's narrow it down to New Hampshire a little bit. Sherry did a marvelous job of laying it out, some of the aspects of New Hampshire. I'm going to talk about it from a specific water point of view. This chart covers our period of record for the last 120 years, and it's a bathtub chart. That is, it estimates how much water flowed out of New Hampshire each year based on gauging that we have on rivers across the state, and then they backwards sum it all together and develop an estimate of how much water went out of the state. And you can look at the green line as the 120-year running average of where we're at. If you're a periodicity kind of person, you look at it and go, well, I'm seeing more extremes on the right-hand side than I am on the left-hand side. And that's entirely possible. But we're also seeing a lot of indicators of what's been happening in terms of major events. So for example, you see the drought, the last multi-year drought we had of 16-17. You see it there. Before that, the major drought of 02-03. And before that, our drought of record, 64-66, which really cut deeply into the water resources of the state. But you also see the floods of record, the floods of 36, 37, 38, that time frame, which were really substantial, and I'll talk about a little bit further on. And, you know, we have to look at both sides of this extreme events. We have to look at the drought side, and we have to look at the precipitation side, because I'll tell you, I'm worried about both of them into the future. Next slide, please. So let's talk about the drought first. The chart in the upper left, you can see the two heavy lines, the heavy black line and the heavy red line, are the snowpacks of the last 2 years. And one of the reasons this chart is important is because when you talk about snowpack in New Hampshire, people say, well, how does it compare to the average snowpack? Well, when you look at that data there, and these are measures by week of the amount of snowpack at a particular set of gauges of stations in the Winnipesaukee River, Lake Winnipesaukee Basin, the watershed, you can see that that really doesn't look like an average distribution, a standard distribution. And if you're going to talk about the average of something, you got to have data that's shaped in a certain way to enable you to draw conclusions about how the median, the average behaves. And that's not exactly correct for the snowpack in this particular watershed. A more powerful tool is to look at it in terms of how does it compare to all the snowpack that we've seen. And that's what this chart does for us. And the bottom line, as you can see for the last 2 years, is the snowpack did not do well. And we saw it coming as early as late January. And this to me is a very good lead indicator of whether we're going to have a drought or not within the state. Now the chart on the right shows why the droughts, these last 3 that I'm talking about, the ones since 2000, have continued. Most of our droughts, as Brandon has pointed out, end with a tropical storm or two coming up the coast in the late fall and giving us all the water back that we didn't have across the summer. And every tropical storm that we had that was due to come and do that for us last year missed. And you can see the Concord area, which was Concord and East, which was the area most severely impacted in the late summer and fall timeframe last year. And you can see how the tropical storm went right up the Connecticut River Valley, and most of the precipitation, as they do, occurs on the left-hand side of the storm track and deposit all that moisture there instead of on us. And that really resulted in the chart in the lower left where you see the peak of the drought as we saw it last October, and the impacts, for example, on North River in Nottingham is shown over on the right. I mean, that's not a river anymore. That's a rock bed. And you can imagine what the ecological, the environmental, the biological impacts of that are on that particular stretch of river. So that's the drought as we've seen it to this point. Go ahead, next slide. And here's how it compares. The chart in the upper right is worth a few minutes to take a look at. This chart illuminates what droughts have been for us for the last 20 years. And we like to say, if you can't see a problem, you can't solve it. And so this helps illuminate the last 3 droughts. And what it does is it shows how much of the state by percent, so the vertical axis is the percent of state, has been in the different levels of drought, D0 through D4. And D3 is the sharp red that you see right there. So we hit D3 in 2016-17. We hit it again in 2020 last year, and you can see back in 2000, we didn't hit D3. We had a larger amount of D2 across the state. Now here's where I'll go into a little bit of forecasting for you. So last week, the drought map, as you can see in the lower left, actually decreased. So it had been increasing on April 6th, April 13th, growing and growing. And then we had a couple fronts that went through, and the drought early warning system folks that we're a member of them as a discussion group that pulls together all the data on surface water, precipitation, agricultural impacts, on and on and on, groundwater measurements, and these kinds of things, said, okay, we've had a little bit of recovery and the map decreased. Tomorrow's map will come out. It will be pretty close to status quo based on the discussions that we're watching and participating in. But after that, I think the drought is going to rebound, and we will see drought increase across the summer, June, July, and may get quite severe into the August, September timeframe. Whilst I hope not, as a professional pessimist, this is what I think is going to occur. And so I would ask all of our water systems and community planners and managers to consider very carefully where we're headed for the drought this year. In the larger picture of climate change, one of the things we're doing is we are funding UNH team, Cam and Mary Stampone, Cam Wake, who was pictured earlier doing his ice cores up in Nepal. We are funding them this summer to update the reports that Sherry referenced, or those very sophisticated charts that she showed you of what it looks like in the future. All that work that they did was based on data up to 2010. And then a report published in 2014 was based on that data to 2010 and on the computer models as we knew them in the 2012 timeframe. Well, as you know, there have been a lot of advances in computer modeling and computers themselves, massively parallel supercomputers, so on and so forth. And a lot of those need to be updated. And so Mary and Cam and their team are going to update the 2014 report for us and publish that into the fall to give us a better viewpoint of, based on what we now know and based on what the improvements in models have done, What does it mean for New Hampshire in terms of extreme events like drought probabilities in the next 100 years and extreme events like precipitation? What are the probability changes in the next 100 years? So we're looking forward to that report, and we were very pleased to fund that. Next slide, please. I can also talk about other things we're doing in drought, but the key issue is information. Information is our primary weapon system to arm people. Some people are getting the message, as you can see on the left-hand side. That particular person understands that their well water probably shouldn't be used to keep their grass green. The person on the right-hand side appears not to have gotten the message or decided to ignore it. And so this is a good example of how we need to work harder to make sure the message gets out and people understand the implications. Because as you all know, the groundwater underlying all those homes right there is the same source of groundwater, and they all impact each other to some degree. Next slide, please. So let's talk just very briefly about sea level rise. Sherry teed this up very nicely for me, and I appreciate that. She talked about the New Hampshire coastal flood risk summaries and the guidance, part 1 and part 2 shown on the left, and you can go to the cause website, pull those reports down. And I just want to dwell on part 1 for a moment. So even within the political and other climate that we were experiencing over the last 5 to 10 years as regards climate change, a very large team of people, UNH and many other researchers came together and produced an agreement document on what the science was telling us. And that was achieved, you know, I view this as one of the major decade-long type projects that the department has been working on, like the Great Bay Nitrogen General Permit, like the Lakes Trends Report that were published. These are 10-year-long projects, and this was one of those also was published. And as Sherry pointed out, if you look at the chart on the right, it's a little tough to read when you first look at it, but if you look at line number 4, the central estimate of what everybody agreed to is we are headed for a 2.5-foot sea rise in the next 80 years. 2.5 feet in the next 80 years. The best and brightest minds in New Hampshire and those that would contribute nationally and internationally to the effort said that's what we're looking at. That's based on carbon, essentially based on carbon already in the system. I don't think the state of New Hampshire has internalized that number yet. I don't think people living on the coast, by the way, the real estate market on the coast is hopping. People are buying homes that are already getting their feet wet under king tides. I don't think New Hampshire's communities, homeowners, industries, and other aspects have really understood what a 2.5-foot sea level rise is going to do to us. And I'll just end my thought on sea level rise there to say, when people start really understanding what 2.5-foot sea level rise looks like, then we're going to start to see some real concerns come to the table. Next slide, please. The next area is water contamination. Many of you heard me say I have my top five emerging contaminants I'm concerned about: arsenic in residential wells, PFAS, and nutrients. But the other two, salt and temperature, are the ones that are most impacted by climate change. And so I'll highlight those just for a moment. So salt, chloride contamination, or the conductivity that we measure it with in our surface waters, is on the increase. We know that, for example, in Cobbett's Pond, the upper chart, the upper line on the chart to the right, and we can see the conductivity increasing very steadily with a little dip there around 2010, but increasing at a very remarkable rate since 2010 to the point where we're approaching salinity levels of tidal marshes. When we get to 750 in conductivity, you'll begin to see all freshwater species will die off, and saltwater tolerant species may or may not begin to move in. I mean, this is an inland pond. So salt in that pond, which is expected because it's near major highways, major intersection, state and town roads, is up. But more importantly is the lower line. That's Lake Sunapee. Okay, now Lake Sunapee, a little different situation, still subject to some highway chloride, but a lot of other sources of chloride, such as parking lots, sidewalks, driveways, and all those kinds of things around that lake, one of our most pristine water bodies. And look at that chloride level coming up, basically a 25% increase in 25 years. That is very concerning. Salt is elemental. The only way to get it out of your system is to wash it out. And in order to do that, you got to reduce the inflow of salt below what it is now, and then continue the precipitation. This is an area that we're working very hard in, and we're making some progress based on some legislative efforts to get a municipal salt certification program into place to help reduce salt. But it's an area that, again, I am very concerned about, particularly under climate change forecasts. Next slide. And it's also being reflected somewhat in drinking water concerns for Merrimack Valley, the Merrimack Village District. You can see their salt contamination in some of their wells, that particularly MVD3. And you can see the chloride contamination over the last, 20 years. You can see the variations on a seasonal basis, but you can also see that on a average basis, it's on the climb. That means that we're no longer getting seasonal impacts. We're actually getting enough residual chloride contamination to create long-term impacts. And of course, salt as a problem is one that we have no one to blame but ourselves in the local area. We cannot hang that on national issues or others. And so we've got to look at it. The drinking water team has been looking at a lot of different approaches to this: advocacy, intellectual investment, pragmatic capital investment, and to include the interconnections piece that Brandon talked about, which is becoming so important, infrastructure resiliency and flood preparation. And then I'll talk a little bit more about development and floodplains a little bit more. And then finally, wetlands protection. This circles back to the drought also. We've done a back of the envelope estimate. And over the last 50 years or so, based on the amount of wetlands that we have lost in the state of New Hampshire, we've lost somewhere between 10 and 30 billion gallons of freshwater storage. You know, depending on how you count it, that's something on a 7 to 70 day supply of fresh water for the population of the state, which is about the amount of time that we were at D3, for example, last year. So 10 to 30 billion gallons of fresh water is a substantial amount of water. And so wetlands protection is another theme that I think is very, very important under climate change considerations. Next slide. The other water contamination I mentioned I'm concerned about is temperature. We certainly saw that in the Lake Trends report that I mentioned earlier that came out late last year that is available on a variety of websites. Again, it was one of these 10 years to get the report published, but many, many years, you know, decades, and in one case, a century's worth of data collected together on a variety of critical measurements for the health of our surface waters, our lakes. And one of the key ones are there's ice out dates, and you can see the chart in the upper right of when we're seeing ice out dates. And ice out dates, and reflectively also ice in dates, have been changing due to climate change. That is a measurable impact, although it does have a wide data set because of the more data we collect in the last 25 years than in the first 50 years of the century. But nonetheless, you can see a trend there, and it's mathematically supportable. A lot of different aspects to that. There's studies now at the international level that lakes that lose ice cover also change in their water quality characteristics. So you as professionals in drinking water considerations need to start thinking about that. And of course, then there's the other effects that we're so much more familiar with, cyanobacteria and many other aspects that come in with warming lakes. Next slide, please. And then finally, extreme precipitation. This is an area I was a responder to Hurricane Maria down in Puerto Rico, and some of you have had the opportunity for me to talk a little bit about that. This particular picture in the upper left is Guajaraca Dam, which is a major dam in upper part of the island that was essentially there for drinking water. And in fact, you can see, if you look at the picture closely, you see that bluish green facility in the lower right of the picture. That's a water treatment facility that was drawing water from the reservoir and then pumping it down, supported about 20 to 30,000 people down in the valley below. You can also see the failure mode of this dam. The dam didn't fail. What failed was the floodway, the emergency spillway. And that's the water that you see coming over on the right-hand side and then cutting across to the center of the picture. And the bottom edge of the emergency spillway failed. And you can see that essentially the water is digging a hole at the toe of the dam. Digging a hole at the toe of the dam is a phrase that makes dam engineers very, very concerned. Because when you dig a hole at the toe of the dam, you put the dam at major risk. And they ended up evacuating several major communities downstream as they'd be concerned about a potential failure of this dam. So there's a lot of different implications to that. Hurricane Maria was a major event, a major hurricane. like the major hurricanes that pummeled the East Coast, particularly the central East Coast of the United States and south of that, sort of the area that I mentioned earlier where New Hampshire is headed to. So I'm very concerned about extreme precipitation events of 10, 12, 14 inches in a 12, 24, 48-hour period. The last time we experienced rain of that type, as I mentioned, was in the floods in the mid-30s. That's a picture of Nashua on the left and Manchester on the right from those major flooding. There are structures in place now that were designed in the 60s, built in the 70s, that are designed to help control the Merrimack River from that kind of flooding. But that's exactly what their problem is. They were designed in the 60s with the best data and analytic tools we had to that point. They were built in the 70s with the best construction techniques that we had at that time and design specifications and construction specifications. And they are reaching the end of their 50-year lifespan. And so, well, I'll just let you think through that. We have about 2,300 dams, of course, across the state, like the one you see in the upper right, that DES regulates. Many of those dams are in not good condition, and a major precipitation event coming through New Hampshire would have very, very serious consequences in a lot of different areas. Next slide. So now I'll take a 30-second commercial break from all the different areas I've walked you through, and say, as the commissioner said this morning, we need an assistant commissioner, and with my retirement, we need a water division director. So if come to the dark side, we have cookies, and if you're interested or know someone who has the skill set, the ethics, and the technical foundations to take on one of those two positions, please give us a call. We'd be happy to talk to that person. We'll not even dime you out that you gave us a name. We'll keep you anonymous if that's what you like. Next slide, please. So where does that bring us? So Tom, you've laid out this set of 4 major areas that you're deeply concerned about, and what are you thinking in terms of what to do about it? And I'll tell you, this little chart is not one of those, the one on the top one on the left lines up with the one on the right. This is all those problems on the left need all these approaches that you see on the right in order for us to be successful at them. And the first is we've got to back up. Okay, we got to back up from the coast. We can call it managed retreat, or we can call it retreat, or we can wait till the ocean just takes it all out to sea. But we have got to back up, and we've got to back up in a smart and effective and economically supportable way. We've got to get out of the floodplains, stop building in the floodplains, and we've got to realize that the floodplains are there for a purpose, a very important purpose for our society, and we've got to do this slightly more expensive construction in the uplands and reap the long-term economic benefits of doing it that way. We have to look at integrated land use planning, and Paul Suska and his team, along with Lori Summers over on the wetland side, have been participating with NRCS in some initial conversations to try to build on the work that the legislature did back in 2014 to say, look, we've got more organizations walking around with more money than you can shake a stick at trying to buy up land for conservation. That's a good thing, but to some degree, they're competing with each other, and they may not be buying the best value land that they need for their particular purpose. They may be buying land that's close to that, what they need for that purpose, but happens to be available. And so we're driving up the prices. We're reducing the taxable land base for many communities. We're having a lot of second and third and fourth order effects that we haven't really planned our way through. We've thought them through, but we haven't planned our way through them. And so integrated land use planning, something to include the wetlands protection piece that I mentioned a few minutes ago, is something I think is critical. We also need a water use culture change, and we could talk about that in a little bit of detail, but people have got to stop taking water for granted, like we do in New Hampshire, to be very frank, and instead start to take water as a critical economic resource that it is. We're already starting to see some concerns on that as biotech firms and others look to move to New Hampshire and realize it for both clean water and for wastewater, that is for drinking water and for clean water, wastewater, that those are constraints on where they can locate important facilities for our economic future. And then finally on infrastructure investment, and Brandon, he gets concerned when I use this example for good reason, but we spent $2.5 million to help out a water system in New Hampshire that serviced basically 60 families. That was great. I mean, that was a solid investment to support them, but that's a lot of money for a very small group of people. And we have to be very pragmatic. We do not, certainly the federal government does not, after this ARPA round, and this infrastructure bill come through, I'm not sure where the federal government's going to stand in its ability to invest further after that in the future years. But we have to be very, very pragmatic about where we invest to the best benefit of people, the best benefit of their economics, the best benefit of the water as a resource, the best benefit of New Hampshire as a state. And that is not an easy thing to do in a lot of different ways. Next slide. Okay, and I think that covered it for me.
Yep, I think that was your last slide.
Yeah, thank you, Bruce. At this point, again, I just want to say how much I deeply appreciate the team that put on today's conference and the many successful conferences of years past. The Drinking Water Groundwater Bureau does a fabulous job at this conference, and I appreciate all of you attending and the opportunity for me to make a few comments and perhaps cause a few thoughts to you. So with that, Pierce, I'm ready for questions and discussion.
Well, thanks, Tom. And thanks for your service here at DES. It's been, you've been a real visionary and pushed all of us to think creatively and innovatively so that we can work on some of these, a number of challenges across a variety of water-related issues here, including drinking water. And I'll check with Liz on the questions that we've received. I'm not seeing actually many at this point. Liz, do we have a question for Tom? If not, I probably have one.
Hi, yes, we do.
Okay, go ahead.
So this person, I am interested in Tom's perspective on how non-engineers can convince engineers that we should consider natural or green infrastructure solutions to climate change instead of just spending billions designing bigger gray infrastructure. In other words, pipes and hard structures.
Yeah, great question. I'm not sure who asked that, but I'd love to have a sit down, have a glass of wine or beer or what other libation with you and talk it some more. But let's remember, engineers don't do anything by themselves, okay? They work for a client, and the client tells them, this is the amount of money I have, this is what I want to achieve. And they put in the box in which the engineer must work to get to a solution. And so it's the client you have to go to. You have to go to the person who is funding the engineer's work to say, listen, your box is too narrow. All right, you've put in place too narrow of a solution set. You are driving the designers, the analysts, the construction people to a specific solution, and that is where the problem lies. You know, I'm an engineer. My kids are engineers. You know, I come from a family of mathematicians, and so on and so forth. And I've done major construction in the Middle East, and I deeply understand how engineers respond to their clients. That is the driver. And so you've got to go after the client.
Okay, next question. Why did you list arsenic and nutrients as contaminants of emerging concern?
Great question. Let me touch arsenic first. Based on our best estimates at this time, we've got about 90,000 people in New Hampshire today who got up this morning and drank water from their tap with arsenic above the maximum contaminant level, the MCL. That is the level at which we here in DES and the state of New Hampshire believe they are having health impacts, substantial health impacts in some cases. That's a lot of citizens in New Hampshire drinking water that is essentially not good for them. And they live on residential private wells, and they do so for a variety of reasons, by choice or by economic niche or considerations, or for other reasons. They are taxpayers, okay? Those approximately 90,000 people pay taxes, and yet they don't reap the benefit at home of the community water systems that we invest in across the state. And we've got to change that. We've got to take care of those people to the same degree that we take care of people who are the customers of the water systems that many of you represent today, and which you do such a great job of delivering safe water to them. We cannot afford the societal impacts of child development, IQ impacts, medical costs that those families are incurring, and special education costs, which you are incurring when those children go into school. We cannot afford those costs when we can prevent them at a pennies to dollars type ratio. We can prevent them by preventing that water from going into those people, those fellow citizens. So that's where my concern on arsenic comes from. And because it's a naturally occurring contaminant, which is true, it sometimes doesn't get the same attention that PFAS and other contaminants get that also have health impacts because it is naturally occurring. We can't point at a company or an organization and say, you did it to us. Again, as often as the most challenging for us as people is to say we did it to ourselves. And those people are drinking water because they drilled a well into that arsenic contaminated area. By the way, the arsenic contaminated area of New Hampshire is southern New Hampshire, basically from Lake Winnipesaukee down. That's the geology. And so that's why we've got to address it. Now, nutrients is a really, really interesting area. Most of the nutrients, of course, that we're concerned again are produced by us as body waste, phosphorus and nitrogen, with the exception of fish hatcheries, which produce phosphorus as a result of the fish that we want to get out of the hatcheries. But we produce this contaminant, this nutrient contaminant, and so we're responsible for the secondary results that come out of that in terms of growth of various species in the water bodies and the impacts that it has across our waters. And we've addressed it primarily to this point through choking back on the amount of nutrients that are allowed to come out of wastewater treatment plants. We've about, or certainly within the next 10 years or so, we have taken that method as far as we can get it. For the Great Bay area, we've recognized that and have gone to the Great Bay Nitrogen General Permit, a phenomenal piece of work by Ted Deers and the Watershed Bureau and many people who preceded them for many years to get that into place, working with EPA Region 1. I can talk about that a little bit more if you'd like. But the bottom line is our approach for about half the state who are on septic systems. Septic systems, if they work, produce one kind of nutrient. They failed, and we have many failed systems across the state produce different kind of nutrient. But all those nutrients are going into groundwater, and some of them are making it through into our surface waters. And so we've got to begin to get serious about what are we going to do to control that nutrients contamination. Other states that have higher levels of nutrient contamination have already begun to break ground on that, and we're a couple years behind them in terms of how serious we need to be about it.
Okay, next question. Can we demonstrate that green versus gray infrastructure is more cost effective?
Yes. But perhaps you were looking for a little bit more thought of that. Everything depends on the assumptions you make about economic benefit. If you make economic benefit assumptions in a longer term, if you make economic benefit assumptions based on cost of electricity or cost of carbon heavy fuel sources, such as petrochemicals, if you make assumptions on cost of construction at the time of construction, which are different than cost of construction now. If you make these different kinds of assumptions, you change the equation of what's economic and what's not a lot. And so that's, again, we talked a few minutes ago about getting to the client. That's where you've got to look at the economic models that clients use, communities, municipalities, industry, these kinds of people, to say, hey, look, you got a problem with your economic model here, and it's right there. You made assumption that this and this and this and this, those assumptions are not valid, or you use the wrong parameters, or whatever the approach is. I'm speaking a little engineer speak here. Sorry about that. But that's where you've got to address those considerations.
Okay, thank you. Next question. To what degree are domestic water softener and treatment systems contributing to the observed rise in groundwater salinity?
All right, marvelous question. The answer is, to some degree, we don't know. There's a lot of great analysis and testing that could be done on that. There's also a time lag factor. A lot of those salt-based water softener systems went into place in the 70s, 80s, 90s, and it takes a while for that salt to get from where it's coming out of the house to wherever it's going to, which can be in many cases, a lot longer, because some of them are going into their septic fields. Some of that salt's being captured when the sand gets changed out, and some of it's moving on into the groundwater. So relative to somebody salting a parking lot, and then in the spring when the rain comes through, washes it directly into the surface water, that's a direct seasonal impact. For softeners, a much more attenuated or slower movement or transmission of the salt into our surface waters. At this point, we don't identify it as one of the major contributors. And if I had a minute, I could call up the slide. How fast can I get to it? On what we view as the major contributor. But at this point, we view parking lots as the largest single contributor across southern New Hampshire of salt into surface waters. It used to be state highways. State highways were the largest contributor, but DOT has done phenomenal work over the last 10 years to reduce the amount of salt that they use on a highway mile basis, how much per mile. And they've done this through a variety of ways we can talk about. So we've got to go after the other sources now, which are municipal and other parking lots, big Target and Home Depot and these other big parking lots. And we've got to go after them next to reduce the salt that's being used there.
Okay, next question. I'm going to paraphrase this. I feel that radon gas should be on the spectrum of water quality contaminants. What is the likelihood the state will add this to the key list of groundwater quality issues?
Yeah, I mean, radon is already a contaminant that we're looking at, but I haven't yet seen, and if somebody's got it, I'd love to look at it because that's what I base my viewpoints on. If somebody's got scientifically based data that shows how many people are getting sick and being impacted by it, then I would love to see it. And we have some of that data, but we don't have enough yet to say a radon, in my mind, has a larger impact than arsenic. And you got to remember, radon is a contaminant that affects somebody over the course of their life. Arsenic, like lead, is something that affects an unborn child or a young child immediately. All right, that is lead. One dose of lead from somebody licking their hand after running it down a shelf with paint dust on it, paint particles on it, and that's a 10-point IQ drop that day. So to some degree, it's a matter of the time frame in which it occurs. Lead and arsenic operate in relatively short time frames and have very substantial impacts. Radon, like PFAS, works over a much longer time frame.
Thank you. Next question. Will New Hampshire DES consider updating infrastructure design standards with climate resiliency in mind?
Absolutely. We could, whoever's asking that question, we could link you up with some of the experts. But if you take a look at the guidance portion, the part 2 of that report I referred to on sea level rise, has some very specific suggestions. They're not requirements yet, but as many people know, what the state suggests today, they may require tomorrow, depending on how things shape up. But it has some very serious suggestions on culvert installation, bridge heights, and many other aspects for the coastal areas to assist them in adapting to sea level rise. And again, I want to kind of go back. I want to use your question to get back to my key point. I'm not really sure that our coastal communities really understand what a 2.5-foot sea level rise means. We were in a meeting just a couple months ago with a contractor for one of our communities on the coast who was describing a very sophisticated project and wanted our viewpoints on it, to which we were happy to give. But 3/4 of the way through the project, someone asked a very simple question: how are you incorporating sea level rise into this design? And of course, the engineer went, we're not. It was not required by our client to do so. So it's a good example also of that aspect, to which we looked at the client and said, you got to go back and rework that. You cannot allow this design to go forward under zero sea level rise consideration, because you're kidding yourself if you do that. And I'm paraphrasing the conversation very heavily, obviously. And the community did go back and told their consulting engineers, okay, hold on, let's go back to what we're working on here. We gotta rethink this.
Okay, next question. Are there any concerns about pharmaceuticals in drinking water?
Yes. Well, I would let Brandon. Brandon, are you out there?
Yeah.
Yeah. Brandon, you want to take a first shot at that on pharmaceuticals and drinking water?
Yes, we certainly are concerned and have done a number of research projects over the years. One around a nursing home on a septic system on top of a hill with private wells nearby, and you certainly can see pharmaceuticals and personal care products in the groundwater. We didn't actually have access to the private wells nearby. We saw them at the perimeter site. We also saw floor cleaners and other things that typically go down a septic system. There was another study, and I've presented at prior conferences, and I can dig up the presentation on pharmaceuticals and personal care products in the Merrimack River, both where USGS gauges the river and also at the discharge sites of all the wastewater plants. And there's over a dozen wastewater plants, and so we can share that data. what we lack is health risk assessment information on these pharmaceuticals, and it's something that we've worked with other state drinking water programs to encourage EPA to get more aggressive on looking at chemicals of emerging concern. And there's actually a report that a number of state drinking water programs wrote, and I could send anyone about how EPA should revise how it looks at contaminants and be better at adopting recommendations, especially for man-made contaminants, for which there hasn't been a new MCL at the federal level adopted since 1995. So worry about that, as well as a number of other chemicals that don't quite fall in that category.
Thank you, Brandon. And by the way, I want to highlight this is what a water division director does. I am deeply dependent and happily so on the expertise of my bureau administrators, the 8 that I have on my team, and their experts that they have out there with them. I would just add to Brandon's comment, there's a big difference between elemental contaminants like phosphorus, nitrogen, chlorides, and PFAS, which do not break down, or PFAS does not break down in our lifetime, as opposed to the very complicated organic chemicals that are represented by pharmaceuticals, which will break down much more quickly. Now, that doesn't help us if the contaminant is right there and it already existed, you're drinking it. But it does help us in the larger term issue of how to deal with it. The elemental contaminants, like the ones I just listed, are a much more serious problem.
Okay, and that does it for our questions for Tom. I do have one thing here that Paul Suska put out regarding green infrastructure. He can point people to some economic studies regarding green infrastructure. So if you're interested, you can contact Paul Suska, or you can contact me and send me an email, and I can put you in touch with Paul.
Thank you, Paul, for that. And also, Paul's given me a great example of what the point I just made about how much we depend on the technical experts, the very serious professionals like Paul and his team represent. So thanks for that, Paul.
Great. All right. Thanks, Tom. Thanks for the presentation and information. That was really wonderful and insightful. And again, thanks for your service. I know you're leaving in less than 2 weeks. So